Thank you. So, good afternoon. My name is Mark Hoffmann, and today I want to talk about data streams in OSGi applications. Nowadays, at first I want to introduce myself. My name is Mark Hoffmann. I'm a co-founder of the Data in Motion. Our company is located in Jena, in Germany, and since last year we are a member of the OSGi Alliance and working in different expert groups. We are a OSGi related company and as well model-driven company with all the EMF stuff. Maybe you heard of it. Yeah, these are our main topics is consulting, development and training, but our main area is currently OSGi. What do you have to expect from this talk? I want to tell you something about messaging in OSGi in general, and maybe you have heard some talks about Pushstreams before. I will give you a short introduction into Pushstreams because there were another talks that went more in detail. I will show a real-world example. And that's the major point. I want to show how to handle different types of messages of different protocols in just using one API. I will show you message pipelines that uses Pushstreams, and I will show how to handle all these different messages from different protocols, putting in one stream and then process data or work with it. And I will have a back pressure example from the real world. I think I will explain something in code and will show you all the topics in code later. So let's first, messaging is nowadays very, very important. There are different protocols, different frameworks and such stuff. And especially in the IoT world, every company that provides a sensor or something like that tries to use its own protocol and what fits best for their product. So we as a company facing the problem that we have many, many sensors we have to bring together in one application, in one backend system, for instance. And we have protocols, for instance, just to name a few, MQTT. In the IoT world, we have Websockets, we have XMPP, we have hardware-based messaging systems like the CAN bus and CoApp. So the point is, every sensor defines the speed of which he provides data to us. There are some protocols like RTP or RTSP which are streaming based, where you can give the back pressure back to the protocol, but many of them are just push based. The data arrive at my listener and that's it. So, and Tim Ward described the problem before, a few hours before in his talk, and I will show the problem in practical way. So, what is messaging in OSGi? OSGi has the event admin spec, which is a foundation in the OSGi enterprise spec. And it's the OSGi way of publishing messages and receiving messages in OSGi. There is the event admin service, and you can publish events in a synchronous way or asynchronous way, if you like. And your listeners, a message handler, can be provided as service in the service registry, just using the whiteboard pattern. I don't know if you know the whiteboard pattern in OSGi. It just has to register your handler as listener, and then you can describe on your topic you want to hear and work with LDAP filters like ordinary OSGi services. And that's one major point, and it works within an OSGi framework, and there are the remote event admin specs which provide possibility to work with in different OSGi frameworks per remote communication. A further RFC that we are currently working on is an MQTT adapter. This is RFC 229 for those who are interested in. And this is just MQTT specific implementation. Tim Verbil did a sample implementation currently. I think he uses it in the train setup in the foyer. That's what he uses. And the MQTT adapter is, just a simple service interface. It's configurable, and it uses Pushstreams for receiving data and simple publish methods for publishing data. So one major point for the MQTT stuff are the Pushstreams. As you heard today, Pushstreams are new in OSGi Enterprise R7, and they are similar to Java streams, but they are push-based. And you have a Fluent API that uses OSGi promises, for instance, and you can use it outside the OSGi world. It's not just related to OSGi frameworks. You can use it in every application you want, and the dependencies are very, very small. You can, for instance, merge streams, which is one of, for us, powerful feature. If you have certain streams from different protocols and different topics, you can merge them together into one push stream, and then you can process this whole stream of data, if you like. And you have back pressure handling, which is very important for us as a company. We currently have a project where we're working with RTP, and RTP is a protocol where you can submit the back pressure to the sender, to the origin of your data, remote devices, wherever the stream comes from. And that's a really good thing. And you have things like coalescing and windowing. We name it batching, which is very handy if you use it, for instance, in databases. What have we done? We created something like a message adapter. This is a small interface. This is inspired by the MQTT adapter, but not MQTT specific. It's more general. Currently in our demo, we have an implementation using MQTT per ho and Websocket clients from Jetty. But you can simply integrate many other protocols, whatever you like. For instance, even RTP or even REST services, if you like. The new REST specification provide a push mechanism and asynchronous handling of responses and requests, and you can even put all your web requests in such a push stream, for instance, if you receive one, and then work on it. The message adapter is, for us, the connector to the outside world, to all the different protocols. All we need are the specific implementations, but to work with it, we only have to configure with a small set of properties, and then we can go on and connect us to MQTT, WebSockets, whatever. And with this interface, even with the MQTT adapter, it's very, very simple to submit all these data into the event admin system. You just have to connect to your push stream and cause the event admin to create events and submit it to the OSGi framework, and vice versa. So now I will begin with my showcase. At first I will show you some code, the basic interface of the message adapter, and the idea behind it. I will give you a look into the implementation of the Websocket and MQTT implementation to see how it works in general. And then I have prepared some use cases that show you the power of the Pushstreams. Maybe you have seen some demo before from Tim and maybe in other talks, but these are real-world use cases to give you a clue how you can use it in your application. So, I hope this is big enough. So this is just the small interface of the messaging service. It includes just some messaging constants, and it has two major subscribe methods. One just to subscribe on a topic, and a second one to subscribe on a topic with a given message context. Usually, if you want to use MQTT, you want to provide some certain options to customize your subscription. Maybe the quality of service or something like that. And that's possible with the message context. And on the other hand, you want to publish messages, and then you have two methods: to publish on a topic a byte buffer content, and on the other hand, publish topic content with a given context. So when we look to the MQTT service, for instance, which is an implementation of this interface, then you will see that you simply have to configure your MQTT client, which is the ordinary per-ho client, and it's configured using the ordinary OSGi stuff, deactivated, closed, and yeah, we have an implementation of the MQTT callback. This is the point where the message arrives, or all the information from the client arrive, delivery complete, message arrived, connection lost, and so on. We only implemented message arrived for the moment, and want to show how the subscription works with the context. That's the point I will talk about now. This context object is just a marker interface. It's just empty, but you can overload it. For instance, there is an MQTT context which contains information about quality of service, retained information, and things like that. It's up to you and to your implementation to extend this context, and you have to create a context builder, which is a simple builder pattern which implements the message context builder interface, so you can create fluently a configuration, a message context in your application if you need it. In our web service implementation, we don't need any context. There's no possibility in Jetty to provide further options on subscription or on submit. It's very simple, but here in this case we have just context builder that sets our properties. So the MQTT service itself has these implemented methods from the interface, publish and subscribe, and what we do is just checking the context, setting default quality of service in our case, and then we subscribe on certain topics, doing some replacements for wildcards, and then we get our event, a push event source from our subscriptions, And if we don't have one, we create one. The simple push event source is an implementation that comes from the Pushstream framework, and you can use it to put your messages in it. So what you have to do then is just create a push stream from the event source. We have seen this in the other examples today. It's just very, very simple. But what we need is not just a common interface, we also need a common message object. And that's another important point. We have in our adapter, in our message adapter, a message object which is defined in the topic and a payload. Maybe it's possible you can include the message context in it, which was probably a good idea. And for simple cases, we implemented just a simple message object. So if you like, or your implementation needs further, more difficult message object, it's possible too. You just have to create your own one, and then you can submit it over the pipeline, over the push stream. Yeah. So this is the subscription, and the publishing is even simple. You just use the MQTT per whole client and publish topic and your content. In some frameworks, you have to create an own message object or a custom object. At this point, you can do this, and then you can publish your content to the outside world. This is the MQTT implementation. It's very, very straightforward and small. And let's take a look to the Websocket implementation, which uses Jetty. It's nearly the same. We have the Jetty WebSocket clients, and we have some holder objects which contain the WebSocket sessions we need, and the push event source objects, and then it's nearly the same. We activate it and deactivate it. We subscribe while creating a session. When we create a session, we just start the WebSocket client lazily and just connect to a certain URL and creating an event source, registering an adapter. In this case, we have a message adapter. You can use for Jetty a listener too, in the same manner like an MQTT. I didn't do that because they have a already implemented version, basic version, and I use that in this case. That's what we do in create session. Yeah, and then you just have to create the stream from your event source. It's the same like in MQTT. It's very, very simple. Publishing is the same thing. We just get our holder, get our session, and then we send the content away. Very, very straightforward. So, and that's it. The only thing we have, I want to show you now, is the adapter itself, which just sends the message. Here are our callbacks from Jetty: WebSocket closed, WebSocket connect, WebSocket error, WebSocket text. And this is what we do here. We just get our event source, create a simple message object, and publish it to the push stream. So that's it in theory, but in reality we need some use cases. This is just the implementation, and I have some examples here, which are all tests in integration tests using OSGi. And in general, what we do is we always set up our message adapters for MQTT or later WebSockets using the config admin. And then we connect just to the Pushstreams and take a look into the Pushstreams. I think the publishing itself is very simple. I don't have to explain that in this talk. The Pushstream stuff is very, very interesting. So what we have here is we have a MQTT configuration which configures just our MQTT adapter. Then we get our messaging service, which uses now the implementation MQTT. And then we publish on a certain topic, which is MQTT temperature, a start command. This is, I did it on the background. We already have started some other MQTT clients, which posting on demand messages to the broker that we can receive. So these 3 clients simulating your sensor or your embedded device, whatever you can imagine. They simply send JSON messages to us. And at a later point, I will show you the same for WebSockets. That's because I already started a WebSocket server, which does the same thing. I send a start command and they start to send. And on the end, I stop them again. So they stop printing it. So I think in this case, what we want to see is just this stuff. This is the Pushstream stuff. And what we have here are 2 Pushstreams. We subscribe for the same topic, getting 2 Pushstreams, subscribe 1 and 2. And then we are working with a pipeline. On the first one, we just print out a new string from the content. What we get is a message in the Pushstream, and we get the payload from it and create a string very simply. In the second one, we using a filter and filter for a certain string, and before that we have to convert the message into a string object before we can filter on a string. And that's what we do in this callback, which does the same like the Pushstream 1. So let's take a look into it. So now we see the Pushstream 1 sends our JSON file, and we have now the second one starts. The second client starts. The first one provides information from the kitchen, the second one from the office. So, and we see stream 1 shows us all the JSON files, and stream 2, which contains a filter for the kitchen, no for the office, just shows us the office stuff. So that's the first one. Now the second one. Now we start using WebSocket connection 2. So we set up just not just only the MQTT adapter, we have a new second instance of our message adapter using our our WebSocket implementation. The properties are nearly the same, just some differences. And so we wait for our messaging MQTT service and the service for WebSockets. What we then have here are 3 subscriptions. We have one subscription on a topic temperature. We have an MQTT subscription for the topic wind, and the third one subscribes to the WebSocket service with another path. And what we do here is, in the first one, just printing out the basic informations coming from our message, and in the second one and third one we convert the messages to string, filtering, and printing out our information, which is really basic in this case. So we're starting with the temperature client, which comes over Pushstream 1. And now we get the wind information over Pushstream 2. And in a few seconds, the third one starts with Websockets. Very, very simple. 3 push streams with different data models, as we see. The JSON files are a little bit different to each other. Temperature has other names for location, client, values are similar. So that's a little bit different. We have different data models coming from different sensors, for instance, and we have now 3 push streams. Usually you put it into a database or something like that, but sometimes you will do more fancy stuff. So we go to the next example, and now we're merging push streams. It's the same like before. We have a WebSocket implementation using a WebSocket implementation, using MQTT implementation, and after that we create push streams. In the same manner, MQTT, topic temperature, WebSocket, wind, and what we do here is we take the subscriptions and merge them together. And after that, we map them from our message object into a string, and then we just print it out. So we're starting with the kitchen, and we see the printout is just from one push stream. Then we get the garden information, and now we have the WebSocket information. Now we have connected 3 sources into just one push stream, and we are doing our processing just on one stream. I think that's a really cool stuff. But sometimes we need some further processing. And the push stream support something that's called coalescing. I hope it's correctly spelled. And which is some kind of batching. We do the same like before. We merge our streams and work with it. But what we do, we say take 5 messages and putting them together. What we get is a collection of objects. In our case, we get a collection of strings because on the mapping before, we converted the message object into a string. So what we get here is a collection of strings, and I do some replacement with them, and then I just print out what we got. But it's a little bit different. So what we have here, the for each is working now for the batched collections. So not for every message, so but for every 5th message. So let's show the result. It takes a little bit longer because we're waiting for 5 messages. And now we have here the concatenated messages in the printout. These are the concatenations of these 5 messages we capturing in the coalescing mode. Not enough. Now we come to the back pressure thing, which is very, very important because, as Tim already said, some sensors define the speed they send a message. And I, as a consumer, have to work with it. we're having information that will only be sent one time, and then they are away. So what we have to do is to work fast enough, and sometimes we are not fast enough. So the push streams support back pressure. What we did in the example is we're adjusting the back pressure directly and saying, I can say all my clients that send the informations have a speed from about 800 milliseconds or 1000. And now I say my consumer will be slowed down to 1.5 seconds. All the other stuff is the same. The only thing I do is print out the time it takes. And on the other hand, we have a second stream without this back pressure configuration, and we can show how it works. Tim already has shown that that the push streams have a buffer included, and you have to take care about your buffer. It's not endless, and it can cause you an out of memory problems. So I will show you how it really works. So you have to take care about that. And we already start here. And here we see how long the consumer took. The push stream without back pressure took about this 1 second, how the messages are published, and the second one with the back pressure configuration took 1.5 seconds. And now at this point, all message providers stopped. No sensor is providing any message anymore at this point, and we see that the back pressure push stream still delivers data from the buffer. So if we get it run a little bit longer, then we get an out of or a buffer full exception, and everything will stop. So you have to take care about that, but that's a really good feature. So because the time's already over, I have another showcase which shows you just how simple it is just to store all the data in the MongoDB. For that we use an internal system which creates a MongoDB client and a Mongo database in an OSGi way. And we do this in this way, just doing the connection to our MongoDB, which is running in a Docker in the background, connecting to this database, and then doing the same coalescing part we've seen before. What we do is we convert this message not into a string, just into a JSON object. I use simple JSON for it, and then we save it into the Mongo database. We can look at the convert method, which is quite straightforward, and just copying the map into just parsing the string into a JSON object, or in case of an exception, which can happen at the end of a stream or on arrows, then I create a failure object, and the storage into the MongoDB is quite simple too. We have our database provider service getting the Mongo database, and then we create or get the collection, taking all our JSON objects, stream them, map them into documents, into JSON documents, and insert many. We're using coalescing mode, so we're batching 5 messages, converting them into 5 objects, and then we store 5 objects in one time into the database. So it looks the same. And what it does is for each batch I create a batch ID, which is just a counter, and it will insert it into the JSON objects and just stored in the database, and we can see all these informations in MongoDB in our batch find pretty. Can you see it? So here are all our data sets in the MongoDB, and we have the batch ID here, which I have inserted. These come from batch number 2. This one is from batch number 1. And that's it. So I think that's all. Time is running out. So yeah, I say thank you for listening. If you're interested in further informations or the implementations, we will provide this on this GitLab site. If you don't have it, it's in the slides. The slides are provided on the page. So, and if you have any further questions, just contact us. So, thank you very much.